Hello everyone. Good morning. Am I audible? Yeah, perfect. Okay. So, we were talking about something called as collection, right? Okay. So even today we are going to talk about something called as collections only. Okay. But it's the continuation of it. Okay. So make sure whatever we did from past 3 days here. Okay. So you try to understand that in a beautiful manner here. Okay. So yes, okay, so all these days here we spoke about a lot of important topics here. Okay, so initially we kickstarted the session with understanding what is a data structure. Okay, so data structure is nothing but it's a way of storing or organizing the data. Okay, so the famous data structures are stack, queue, linked list, and so on. Okay, and then we also understood what is collection, right? So collection is a predefined interface in java.util package introduced from JDK 1.2, and it is used to store a group of objects. Okay, collection is used to store a group of objects, and we also spoke what is collections here. Okay, collection is a interface. Collection is an interface. Collections is a class. Okay, and we saw the difference between collection and collections as well. Under collections we also had a method called a sort method. Okay, wherein it was used to sort the list here. Okay, so this is what we are supposed to understand. So collections is a predefined class in java.util package, and collection is a predefined interface in java.util package, and both were started from JDK 1.2. And we saw the collection hierarchy now. Okay, we saw the hierarchy of collection. Okay, so how does it work here? So iterable is the supermost interface. Under that we had collection. Under collection we had three sub interfaces: list, queue, and set here. Okay, so these were the three interfaces: list, queue, set. They are all inheriting collection. Collection is in turn inheriting iterable. Under array list we had four implementation classes: array list, vector, stack, linked list. Under queue, linked list, priority queue. Okay, under set, has set, linked has set, tree set. Okay, so these were the few things here. So make sure you all try to remember all of those in a very beautiful manner here. Okay, and we also saw the difference between array and collection as well. Array homogeneous, collection homogeneous and heterogeneous. Array does not have any methods, but collection has a wide range of methods here. Array does not support generics, but collection does. Okay, and array is fixed size, collection is dynamic in size here. Okay, so these are the few things here, and we saw a few important methods as well: add, add all, remove all, contains all, size, is empty, clear, get method, set method, index of, last index of, blah 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 blah. We have seen thousands of methods here. Make sure you all study all of those methods in a beautiful manner. And we saw what is array list, and we saw linked list as well. We saw the implementation of array list also, linked list also, and we also saw that difference. When do we choose array list? When do we choose linked list? We have seen all those requirements over here. And in yesterday's session, after doing all of those, we jumped into a topic called as for each loop. We know how do we traverse the data with the help of for each loop. Okay, we know how to traverse it one by one with the help of for each loop. And we also saw something called as wrapper class. Okay, the non-primitive version of a primitive data type is called as wrapper class, and auto boxing is converting primitive to non-primitive is auto boxing, non-primitive to primitive is auto unboxing. Okay, and collection does not support primitives, so we had wrapper classes for it. And we also add generics. Generics is used to specify the element type here. Okay, so these are all the topics here, and collections, do not neglect it. Okay, because it's going to be very very important for your interview as well as your project. Okay, so it's vast but it's easy. Okay, so you just need to give time here and prepare for it. Okay, I hope, okay, we're almost towards the completion of Java for you. Okay, I want you all to become strong at it. Okay, it's not that you're good at few topics, not good at few topics. No, that's not going to work out. Okay, so try to study now. At least it's time for you all now. Okay, at least now If you have not put the efforts long back, now it's time for you to put in some extra efforts, okay, so that you can see fruitful results as soon as possible. Okay, so this is what we are supposed to understand here. Okay, clear. Now in today's session, sir, what are we supposed to do here? Okay, so okay, this is the data here. There is a question, sir, please provide notes for collection. I have uploaded one PDF. Okay, if you download that PDF, you have proper collection notes. Okay, you can download that. Okay, if you have opened the link here, you will get that PDF over here. Okay, so you download that PDF, you have entire notes for collection here. Okay, I'll be posting all the programs here. Okay, but the notes, the entire notes, you can just download it from that particular PDF. Okay, and you can prepare your own notes as well. Okay, great. Right. So we have created a project called as collection framework, and we have a package. Okay, day one, day two, day three. And now let us create a new package here, and that package is day four here. Okay, so day four. Today it's nothing but day four. Okay, so now under that, let me create a package. Package, oh, I'm so sorry. Package is already done, right? Let me create a class, and the class name is student. Okay, the class name is student. So now guys, okay, so it's time for you all to, understand this in a beautiful manner. Okay, so here I will have, every student will have two properties, age and name here. So now if someone asks you to explain this particular data here, okay, what are we supposed to do? Package day 4. When I tell package day 4, it means there is a package or a folder by the name day 4. Okay. Public means it's an access specifier. It means the class can be accessed everywhere. And class is a platform or a blueprint of an object. And the class name is student. I'm going to store all the student related properties. Every student will have age. Every student will have name. And I am supposed to initialize with the help of a constructor. Okay. So the constructor will accept the age and the constructor will accept the name here. And I shall try to initialize with the help of a constructor here. Okay, this dot age equals to age. The main purpose of a constructor is initialization, and that is what I'm trying to do here. Wherein the local variables and the member variable names are same. In order to avoid the differentiation, I just make use of this keyword to point to the current object. Okay. Now I'll have one more class. Control N. I create a class called as test class over here. And do you want the main method? Yes, I click on main method until finish. So here I create an student class. Uh, okay. Am I audible to everyone, guys? Am I audible to everyone? Can you all hear me? Yes, no, probably Mahesh, the problem is from your end. Try to log out and log in. Okay. If you are not able to hear me, you just need to log out and log in. Okay, if you're not able to hear me, log out and log in. Okay, so great. So here, okay, see here, what I'll try to do here is, so I will create three objects of student. Oh, one object of student. See, student S1 equals to new student of, and the age of that particular student is 21, and the name is, his name is Tom. Okay, his name is Tom. Clear? Similarly, I will create one more student object, student S2 equals to new student of. Okay, and we have done this process n number of times, right? Okay, the same thing, similar type of programs here. We have done it quite several times here. Okay, so I'm not going to repeat it again and again and again. What is happening when I do constructors? All these things we have done it already. Okay, so I am creating three student objects here. Okay, now here I will have my array list over here. Okay, array list L equals to new array list of, I have created an object of array list over here. So array list is a predefined class in java.util package. So I need to import it from java.util package here. Okay, so I import the array list class from java.util package. So now add method is used to add the data. So I tell add. Okay, now I want to add student objects into my collection. So what am I supposed to do? I need to pass S1. So when I tell S1, I am adding the student objects. S2, I am adding the student2 object. and S3 I am adding the student3 objects. So in simple terms, I have created an object of array list, meaning internally an array will get created of size 10. And I am adding all the student objects into the collection, into the array list. And what are the objects here? Student object S1, S2, S3. But now here, if I tell L dot add of 10, okay, I can store an integer object also. I can store an string object also. See, but now, okay, I don't want heterogeneous objects, guys. Okay, I want to create my collection. Okay, I want to create an array list in such a way it should allow only student objects. It shouldn't allow integer object. It shouldn't allow string object. See, by default, array list can store heterogeneous objects. It can store string, integer, student, monkey, donkey, employee, all types of objects. But now I want to create my array list in such a way it will allow only student objects. So I have to make use of generics and tell please allow this type of objects here. So now tell me what will be my generics type here. Okay, what will be my generics type here? Generics is used to specify the element type, the type of data. Now I want to add only string objects. So I will write it as string over here. If I just want to add only string objects, I will write it as string. As soon as I write it as string over here, it simply means that you can add only string objects into the collection. If you want to add integer objects here, you will just write it as integer. See, only integer objects can be stored, not the other types. Similarly, if I want to enter only student objects here, what will be my element type here? What will be my generics type here? Can you tell me, guys? The generics type will be student only. Why? Because I am telling I am going to add only student objects. So I have to write it as student. Is student non-primitive? Yes, sir. Student is a class. Therefore, it is a non-primitive data type. Therefore, it has to be student. Okay. See, integer object is giving an error and a string object is giving an error. So I deleted. So I have added student objects into my collection. And optionally, I have told you, you can use it at the constructor side as well. Not mandatory. You can use it at the constructor side as well. Okay, that way you can use it. So I have a class, okay, called as student, and it had certain properties. And I am, creating three objects of student, and I have added all those objects into my collection. Now, can I traverse it with the help of for each loop here? 101% I can traverse it with the help of for each loop. But now, what is the type of objects I'm going to traverse? If it was storing only integer objects, I would have written it as int here, int I colon from the array list L, and I would have print the value called as I here. If it was having only integer objects, if it was having only string objects, I will write it as string, wherein only string objects will get sorted. So now it is having only student objects over here. I have only student objects. So the type of data I am going to traverse is, I can write it as student. If not, I can also write it as object as well. It will work fine. Both will work fine. Why? Because if I write it as object here, it becomes like upcasting. Student objects, okay, into superclass reference here. Okay, into superclass reference obj. Okay, that way. That becomes upcasting. But here, since we know it's only student objects here, I can just write it as student over here. Okay, student obj colon L here. So this is what we are supposed to see. In my array list, you have told you have stored only student objects. So now you're going to fetch only student objects one by one, one by one, one by one. No. So that's the reason it is student. So now if I execute the program here, okay, if I execute the program here, look at the output what I get here. I get the three student objects here. Because when I try to print the object references over here, always the toString method gets called and it gives the string representation. So therefore, if I just write it as obj, okay, I will get the fully qualified class name. If I want the content over here, I have to tell obj.name plus, okay, object name dot variable name obj dot the age here. Okay, so that specific data I can make use of it. Okay, so I have to just write it as age colon, and over here I have to just write it as name colon. So that way, when I try to print it, I will get the expected output. See, now when I execute it, the string representation, the content. That way I am getting the output here. So if you want, I can just differentiate it with this respective content. So now when I execute it, see, each and every time here, the fully qualified class name and the respective object data, fully qualified class name, the respective content, fully qualified class name, respective content. If you do not want this, you can override the toString method also. You can override the toString method also and get the output. If not, you can follow this specific structure as well. So this is what we are supposed to understand. How do we store objects into the collection and traverse them in a beautiful manner? So this is how we are supposed to store student objects into the collection and traverse it with the help of for each loop. We can do it with the help of normal for loop also. Okay, for each loop also. The choice is yours. You know how do we traverse one by one, one by one, one by one. Okay, this is all about it. Okay, so if you just ask me one program, sir, can you theoretically explain over here? I'll do it for you. Okay, but concentrate. Okay, I mean, I'm doing it again and again. The only reason being, I want you all to be strong at it. Okay, so here, that's the reason here. I will try to do it here. So understand, guys, I have a class and the class name is EMP, meaning employee. The class name is employee. Now, each and every employee will have a variable called as name. So I will take it as string name. Each and every employee will have a variable called as name, correct? And I want to initialize it with the help of a constructor. So the class name and the constructor name should be same. Okay, class name and constructor name should be same. Open parenthesis close and open curly braces close here. So I have to just make use of this respective logic. So the constructor is accepting certain argument. So that is accepting string name here. Okay, and that particular name, I will store it within the current object here. How do you point to the current object's name? This dot name equals to name here. And I will also override the toString method. Okay, toString method. Okay, open parenthesis close, open curly braces close. So now the access specifier of toString method is public and the return type is string. Okay, and that's an overridden method. And I will write it as return. What? I am returning the name here. So when I try to print the object reference, the string representation gets printed. So now if I do not want this, I will override the toString method. Okay. So this is step number one. I'm done here. Okay. Now here I'll have my main method. Okay. Public static void main string array of arguments open curly braces close. Now here I will create two objects of employee. See here, employee E1 equals to new employee of. Okay, and I have to pass the employee name, so I will give it as A here. So now internally what is happening? When I tell new over here, an object is getting created. Okay, an object is getting created with the address 111. And who is pointing to that object? E1 is pointing to that object. And why did we create an object? To store the non-static variable. Okay, so the name will initially get stored to null. Okay, the name will get initially stored to null here because the default value. Okay, null will get stored. And simultaneously, the constructor will also get executed. Okay, simultaneously, the constructor also will get executed. And what is the name I have passed here? The name as of now which I have passed is A over here. Okay, A here. So the name is A. That A is getting stored into a variable name of the current object. So E is the current object. In E1, the name will get initialized to A over here. So the employee name is, the name of the employee one is A. Similarly, I can create one more object also. Okay, employee. Okay, E2 equals to new employee of. Okay, and the name of employee 2 is, I will give it as B here. So again, when I tell new, okay, when I tell new here, an object is getting created. Okay, object is getting created with the address 222. And who is pointing to that object? E2 is pointing to that object. Okay, and then I have to store the non-static variable, that is name. So the name will get initialized to the default value null as of now, because that variable is declared and not initialized. So the default value is null. Okay, that would have got stored here. Okay, and then simultaneously the constructor will also get executed. The constructor will also get executed. So jig 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 jig, the control goes to the constructor. Here, what is the name now? The name is B here. So what is the name now? It's B here. As of now, this B is getting stored into a variable name of the current object. Which is the current object now? E2. In E2, the name will get initialized to B here. So the name of employee 1 is A and the name of employee 2 is B here. Clear? Done. So now here I will create an array list object. Array list L equals to new. See here, array list. I will just write it as L equals to new array list of. Okay, I am creating an object of array list. So now after I create an object of array list, I need to add those objects. L dot add of. I am telling employee 1. I am adding employee 1 object. L dot add of. I am telling employee 2 object. I am adding both the objects. Now here, as of now, when I create an object of array list, I can store heterogeneous objects. But now I want to store only employee objects. Okay, not other objects. So I will make use of generics and tell I am adding only employee object. So in simple terms here, an array list will get created. An array will get created internally which can store only employee objects. Okay, and E1 is added over here. That is nothing but 1 1 1. And E2 is added over here. That is nothing but 2 2 2. Okay, got it? And the name of the array list is L here. Clear? So you created an array list object and you added both the employee objects. Okay. Now you want to traverse it. Okay. Now you want to traverse it. How will you traverse it? Simple. For each loop. You have to always traverse it with the help of for each loop. For open parenthesis close and open curly braces close here. Now into my array list over here, there are employee objects. So what is the type of objects I'm going to traverse? Employee. Okay. Employee E colon. From which array or collection? L. So I am going to fetch employee objects from the collection L here. And now I will tell SOP, okay, E. So now here, okay, L is nothing but it is nothing but two objects are stored. So E, what he will do, first he will fetch the employee 1 data here. He will fetch the employee 1. So he will fetch employee 1 and he will print E1. So when I try to print the object reference here, E1 over here, toString method will get called. So since the toString method will get called, it is returning the name here. So I am trying to fetch E1 and I'm trying to print E1. So what is the name in E1 here? It is A. So A will get printed. Again E will go. He will fetch employee 2. Now I will print E2. Since toString method is overridden, I will print the name called as B here. So that is how we are supposed to store employee objects and try to traverse the data here. Okay. So this is all about the entire process here. Okay. So now here, if I go back to my program, the similar type I will execute it now. Okay. See here, concentrate. Control N. I will create a class and the class name is employee. Okay. And now in the class here, each and every employee will have ID and each and every employee will have name here. Okay. Then I will initialize it with the help of a constructor. The shortcut key for creating a constructor is Alt Shift S. You'll get the pop-up. Click on generate constructors and I will tell OK. So what happens? See, the constructor got created, which is initializing the data here. And I don't want the fully qualified class name. So that's the reason here I will override the toString method. How? Public is the access specifier, string is the return type, and toString method is the method name. Okay. And what am I supposed to tell? Return ID plus gives a space plus name here. And since it's an overridden method, I will write it as annotation override. So in simple terms, I have an employee class. It has two variables. I have initialized both the variables with the help of a constructor, and I have overridden the toString because when I try to print the object reference, I generally get the string representation. Okay, the default implementation, that is fully qualified class name. I do not want that. I want some content to be printed. So I just write it as override the data here. And next I will have a class called as runner class. Okay, I'll just take it towards the RHS here. Okay, in the runner class, I will have my main method. Okay, I will have my main method. In my main method, okay, I will have three employee objects. See, employee, not encoding. I'll write it as employee E1 equals to new employee of ID is 101, and I'll just write it as we'll just write it as Ambani. Okay, Ambani. Okay, he's employee 1. Okay, then here I'll just write it as then here. Okay, so here I'll write 102, and the name over here is, we can write it as some name here. I'll just write it as Tim Cook here. Okay, done. And I'll have employee. Oh, employee name should be, object name should be different. Okay, okay, so okay, so I'll have one more object, employee E3 equals to new employee. ID is 103, and we can give it as Sundar. Okay, Sundar Pichai. Okay, great. So I have just, I'm just taking the names of those three employees. Now here, I will create, either you can make use of linked list, array list, vector, stack, whatever it is. It works the same way. Okay, but I'm just taking array list over here. It's not that I have to always make use of array list. No, 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 no. You can make use of linked list, vector, stack, whatever you want, you make use of it. Okay, not a problem at all. So you will create an object of array list over here. Okay. Now I have to import the array list from java.util package because it's a predefined package. Okay, predefined class. So you have to import it. Now here into my collection here, into my array list, I want to add employee objects. E.L.E2, L dot add of E3. All the three employee objects I'm storing. But if I tell one integer objects also, it's allowing. Even if I tell, okay, new student object also, it's allowing. See, I'll create new student object, and the age is 10 and the name is Tom. See, I can add one student object also, and I can add one character object also. See, character, okay, character, and the character is Z here. See, I can store heterogeneous objects. When I pass 10, it's an integer object, student object, character object. I can add all those objects here. But now I want to restrict a collection here, a array list, store only employee objects. So what am I supposed to do? Generics. What will be the generics type? I have to tell, please store only employee objects. No student, no character, no integer. Automatically it is object type, meaning it can store heterogeneous object. But I have to tell, hey, array list, store only employee objects. So my generics type will be employee. As soon as I tell employee here, only employee objects can be stored. Integer object not allowed, student object not allowed, character object not allowed. Okay, so you're restricting it. If you don't use generics, heterogeneous type of objects can be stored here. I stored all the three employee objects into my collection, and I want to traverse it with the help of for each loop. Okay, I want to traverse it with the help of what? For each loop. What is the type of objects I'm supposed to fetch? Employee 1, employee 2, employee 3. One by one, I'm fetching employee objects. So the type of objects I'm going to traverse is employee. Okay, employee. And I can give E, MP, colon. From which array or collection? L. So L is the collection. L is the array list collection. It is storing three employee objects. E1, E2, E3. EMP will fetch one by one. E1, E2, E3. He keeps on fetching one by one, and he prints it. He prints this object reference. Since toString is overridden, when I try to print the object reference here, see, I get the actual content here. I get the actual content. If I do not override the toString, see, I do not override the toString. If I execute the program here, I will get the fully qualified class name. Okay, the @ hexadecimal value. See, I get the addresses. Therefore, okay, so if I want override toString over here, it becomes very easy that I can fetch the content here. So you can do it in a beautiful way as well. ID colon plus ID. You can concat this and you can tell name colon. That way also you can concat it so that you'll get the beautiful way. Okay, the output in a beautiful manner. So now when I execute it over here, see here, I'll get the expected output. So even if you don't use it at the constructor side, it's fine. But even if you use it, it doesn't make any problem here. Okay. So it absolutely works fine. This is all we are supposed to understand. This is how we are supposed to store objects, user defined objects into the collection and then traverse it with the help of either normal for loop or for each loop here. Okay. So this is all about it. Okay. So anyone having any confusions as of now here? Okay. So we stored student objects, traverse it. We store employee object, traverse this one by one, one by one, one by one. Clear? So anyone having any confusions, guys, please do let me know here. And this topic, we will be using it widely. Okay. We will be using it very, very widely here. Okay. So there's one question here. Sir, what is the difference between for and for each loop? It's simple. For loop, we have to do everything manually. Okay. If I want to traverse it with the help of normal for loop, no, I can make use of it. Doesn't matter. But efficiency wise, we always make use of for each loop. Okay, so in collections, no, we are concerned with efficiency, a lot of efficiency. In for loop, everything I have to do it manually. See, int I equals to 0, the first index position, I is lesser than L dot size here, okay, L dot size here, and I plus plus here. You know, I have to do everything manually over here. So here I have to print L dot get of I here. So when I tell get off, I am getting the objects here one by one. I get the same old output only. But one thing here is the major difference between okay for and for each loop here is for each loop makes use of iterators concept internally. We have a concept called as iterators. Okay, it makes use of iterators, wherein it becomes very easy to traverse the collection objects here because efficiency is comparatively high. The time complexity is comparatively high internally. For each loop, a for loop, I have to do everything manually. Initialization, checking the condition, updating, everything has to be done manually. So wherein the efficiency is comparatively less here. Okay, so that's the major difference between for and for each loop here. Okay, so we'll try to talk about okay this interview questions as well later. Okay, when I'll tell you what is the major difference between for and for each also. Okay, this is all about it. Okay, so wherein we understood what is for loop, for each loop, and how do we traverse those objects one by one, one by one, one by one. And today's session will be the prerequisite for probably comparable comparator, which I might do it on, okay, today is Wednesday. Yeah, okay. So that might require on Friday and Saturday. Okay, so these two topics are very, very important for the further sessions, whatever we did today. Okay. So clear guys, okay, we are pretty much done with storing objects into the collection. But now let me do one more small topic here, okay, which is very, very important. Okay, that is nothing but vector. Okay, this already, you know, it's almost similar. What is vector here? Okay, we'll try to talk about vector. Simple, we generally don't do vector here because we do no longer use it. But in simple terms, I'll explain it. Vector is a predefined class in java.util package. Okay, it's an implementation class of list interface. See, list we had, under list, we had array list, vector, stack, and linked list. So these are the few implementation classes under list here. So vector is also a predefined implementation class of the list interface. Okay, and it is present in java.util package, and it is called as legacy collection. Legacy collection means very, very old because it was started from JDK 1.0. Okay, it was started from the first version of Java. Okay, it was very, very old here. Okay, so to overcome the problems of vector only, we have array list, actually speaking. Okay, so what is vector? It's a predefined class in java.util package. It's a legacy collection. Okay, legacy collection means very old. When was it introduced from? JDK 1.0 here, 1.0 here. Okay, so now here, what happens when I create an object of vector? See, if I create an object of vector, vector b equals to new vector of, okay, imagine if I create an object of vector here, internally an array will get created of size 10 here. What will happen internally? An array will get created of size 10 here. So it's starting from 0 to it will end it till 9 here. So in simple terms, what did you understand? The initial capacity of vector is 10 over here. So when I create an object of vector, internally an array will get created of size 10 here. Okay, so it starts from 0, end it till 9. So you keep on adding the objects. You keep on adding, 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 adding. So your vector is full now. Okay, so your vector is full now. So once you add, okay, once you add an object, once the collection is full, vector is full, a new array will get created. What will happen here? A new array will get created. And what will be the size of the new array? It is dependent on the incremental capacity formula. The incremental capacity is current capacity into 2 here. So the current capacity is 10. 10 into 2, it's 20. So a new array will get created of size 20 here. Okay. And all the objects from the old array will get copied to the newly created array. Okay. And then the reference which was pointing to the old array gets dereferenced and starts pointing to the newly created array. So in simple terms, when we create an object of vector, an array will get created internally of size 10. Okay. And later, once the vector is full, once the collection is full, and still if you try to add an object, a new collection will get created, meaning a new array will get created based on the incremental capacity formula, that is current capacity into 2. Okay, current capacity into 2. It's increasing its size by 2. And the objects from the old collection gets copied to the new collection, and the reference which was pointing to the old collection starts pointing to the newly created collection here. So it's almost same here. Okay, the underlying data structure is nothing but a resizable or growable array. Resizable array, or we might also call it as growable array. Okay, growable or resizable array. Everything is same, no? See, vector also is same, array list is also same. See, what is the major difference is initial capacity in vector and array list is same. Initial capacity is same, 10 and 10. Incremental capacity in array list was current capacity into 3 by 2 plus 1. In vector into 2. Okay. So it was started from JDK 1.0. It was started from 1.2. The most important difference is, okay, vector is thread safe. Okay. Vector is thread safe. That simply means it is synchronized. Okay. It is thread safe. It simply means vector is thread safe. Only one thread can access the object at a time here. It is single threaded. Okay, thread safe. The synchronized meaning only one thread can access the object at a time here. Whereas array list, okay, whereas array list is not thread safe. Okay, not thread safe. That is nothing but not synchronized. Not synchronized meaning multiple threads can access the array list object at a time. If there is a thread that can access multiple objects can access array list object at a time. So that's the major difference here. Vector was single threaded. Array list is multi-threaded. So always multiple threads has to run, no? That is wherein a lot of things will become efficient. So vector was started from JDK 1.0, no? It was single threaded. Only one thread can access the object. But array list is multi-threaded. Multiple threads can access at a time here. So that's the major difference. Okay. And we'll try to talk about thread safe, synchronized in thread class, threading. Okay. Multi-threading class. Okay. But this is what we are supposed to understand. It's simple, guys. It doesn't matter. It's very, very simple here. See, I'll create a class called as solution. Under solution class, it works the same way. Okay, it doesn't matter here. See, vector v equals to new vector of, I create an object of vector. Okay, and I have to import it from java.util package. Okay, if you want to look at the source code, you can do it. Press Ctrl on your keyboard, hover on the class name, click on it. See here, vector is a legacy collection. Why legacy? It was started from 1.0, long back. Okay, it's almost same. See, array list implements list, random access, clonable, serializable. Everything is same here. Array list and vector is same, but only one major difference is array list is not thread safe, multi-threaded. whereas vector is thread safe, single threader. Okay, and we have the same thing, v dot add of 10, okay, v dot add of 20.45, and v dot add of, I'll write it as dinga. So now tell me, if I want to traverse it with the help of for each loop, what will be the type of data here I want to traverse? I am having heterogeneous objects. It is heterogeneous objects here. I told you one hint here. If it is heterogeneous objects, blindly just write it as object O colon. From which array or collection? It is V. And when I try to print the reference, it works the same way. But only the internal architecture is different. Remaining things are all same here. So what is vector basically? Vector is a predefined class present in java.util package. It's an implementation class of the list interface. Okay. It's a legacy collection. Why? It's very old. Okay. It was started from 1.2. So the initial capacity is 10. Incremental capacity is current capacity into 2. It is incrementing its size by 2. And the underlying data structure is resizable or growable array. But what is the difference here? Vector thread safe, array list not thread safe. That's the major difference here. Okay, this is all about the internal working. So once you create an object of vector, an array will get created. Once the array is full, a new array will get created of size based on the incremental capacity. Then the objects from the old collection gets copied to the new collection, and the reference pointing to the old collection starts pointing to the new collection. That's it. The working we already know it, which we have done it in array list. Okay. So this same differences I have written it down over here. Array list 1.2, vector 1.0. Array list incremental capacity is current capacity into 3 by 2 plus 1. Vector is current capacity into 2. Array list has 3 constructors, but vector has 4 constructors. Okay. And it's also a class, it's also a class. Same data structure, same data structure. Array list not thread safe. Vector thread safe. Vector can be accessed by only one thread. Array list can be accessed by multiple threads. Multi-threaded, single-threaded. Okay. This is all about the entire process about what is a vector and the difference between array list and vector here. Okay. So we did two things today. We understood how do we store objects into the collection and traverse them one by one, one by one, one by one. And then we saw what is vector and the difference between array list and vector here. Okay. And the last topic for the day, okay, which I'll be talking about now. Sir, you told constructors, no, sir. Okay. Array list had some constructors, sir. Vector had some constructors, sir. What are those constructors, sir? Okay, can you explain, sir? 101% I will explain it. So these are the different constructors we have. Array list has 3, linked list has 2, and vector has 4 here. So these are the 3 constructors which we are supposed to understand. So what does it mean here? What does it mean here? I will tell you here. Okay, see here. I'll go back to my Eclipse here. Control N. I will create a class and the class name is, I will just create as demo. Okay, demo, and I'll have my main method wherein the execution will begin from. Okay, so over here, look at the process here. I will create an array list object. Array list A equals to new array list of. Okay, I create an object of array list over here. So I have to import it from java.util package. So I will import it. So now here I am invoking a constructor wherein I am not passing anything. So what happens here? The default initial capacity will get stored over here. Okay, the default initial capacity is 10. So that will get assigned here. If I do not pass anything over here, the default initial capacity, that is the 10, will get stored. If I try to create a constructor, okay, if I try to create a constructor, I mean create an object, and if I pass some data, if I pass some integer value here, it means we are creating an array list object and I'm explicitly passing the initial capacity. So when I invoke the first constructor, it means the default initial capacity will get stored, that is 10. But if I pass int initial capacity, if I'm passing an integer value here, the programmer is explicitly telling the initial capacity. So the now internally an array will get created of size 50. The first example, internally an array will get created of size 10. Why? That's the default initial capacity. In the second example, it is 50 here. So that is what we are supposed to understand. Okay. So we understood these two constructors. Okay. And now here, when I invoke this constructor here, when I just create linked list object, linked list C equals to new linked list over here. Okay. It simply means, okay, I have to store the objects in terms of nodes. When I just create this particular object, no, I don't pass anything over here. It means it is going to store the object in terms of nodes here. That's it. Okay. And then vector. Vector v equals to new vector of. I am creating an object of vector over here. I'll just say it as I. So now I will import that vector also. Okay, I will import the vector also. So now here, when I do not pass any value here, it means the default initial capacity will get stored here. If I try to pass, okay, if I try to pass some number over here, it means the initial capacity was 10. If I do not pass anything, the default initial capacity is 10 and the incremental capacity is current capacity into 2. But if I explicitly pass 60 here, I am creating an array internally of size 60. But if I create one more part here, k, okay, and if I pass 20, comma, and 5 over here, we are explicitly passing the initial capacity as well as the incremental capacity, how many times it is supposed to increase. So in the first way, okay, in the first way, look at the first way over here. When I just invoke vector of the default initial capacity and incremental capacity, that is current capacity into 2 will get stored. Now if I pass only the initial capacity here, the incremental capacity will be into 2 only. But if I pass initial capacity and incremental capacity, I am explicitly telling how many times it should increase its size by. So I will create an array of size 20. Once array is full, I have to calculate the size of the new array. No, that is 20 into 5, 100 into 5, 500 into 5. That way I'm increasing its size by 5 times here. Automatically it is 2 times. It has to increase it by size by 2 times. But now it is increasing its size by 5 times here. So these are the different constructors which we are supposed to use it with respect to collection. Okay. But now, sir, what is the last syntax, sir? Okay, I'll do it over here only. What is the last syntax, sir? I will just give the example over here. Last syntax. Okay. The last syntax is nothing but, see here, I will tell array list x equals to new array list of, I'm just creating an object of array list. Okay. And I'll tell x dot add of 10 over here. Okay. And now when I try to print x over here, okay, if I just try to print x over here, what will be the output now? Array list object got created and I have stored 10. So when I try to print x here, obviously the value will be 10 here. See, I'll get the output as 10. Similarly, I will create linked list object. Linked list y equals to new linked list of, and I am passing one collection into another collection. X is an array list. It's a collection. I am passing that one collection into another collection. Therefore, I tell y dot add of 20 here. And when I try to print y, that is the linked list over here, look at the output what I get here. See, it was 10, now it became 1020. Why? Because linked list I created an object and I am passing one collection into another collection. I'm adding one collection into another collection. So 10 will get added into linked list plus 20 here. So it is 10 and 20. Similarly, I can create vector. Vector z equals to new vector of, and I am passing the linked list y over here. So now I tell z dot add of 30 here. So now when I tell sys out z, okay, what will be the output here? Will it be 10, 20, 30 or will it be 10 and 20 here? So it's simple. So I'm adding this expected content. So the last syntax is nothing but we are trying to add one collection into another collection over here. So this is what we are supposed to understand over here. Okay. So I created an object of array list. No, I told at 10. So 10 will get printed. So this X is nothing but this entire array list I'm adding into linked list. So entire part got added. So linked list I'm adding one more data. It's 10 and 20. So 10 and 20 I'm adding into vector now and plus 30. So it will be 10, 20, 30 here. So these are the various syntax which we are supposed to understand when it comes to collections over here. Okay, so this is all about the entire process for today here. Okay, so in today's session here we have just seen how do we add objects into the collection. Okay, what is vector, what is the difference between vector and array list, and we also saw the various constructors as well. Okay, so this is all about the entire session here. Okay, so anyone having any confusions as of now here? Any confusions as of now, guys? Any questions here? Quickly tell me here whatever we did in today's session. Guys, are you all sleeping? Very good. Okay. So, I just don't want to start a new topic here. Okay. So the next 4 days are the most important topic here. Okay. 4 more days, I'll be done with collections. Okay. One day set, then comparable, comparator, and maps. So all those four topics, if you need to understand, so the four topics which we had done, 4 days, these are all very important. So try to talk about it and get to know about it. Okay. So whatever I'm uploading the videos, the notes are available, the programs are available. You have to just study. Okay. Make some time and prepare well. Okay. So requirements, guys. Okay, so this is what we are supposed to do here. Okay, so requirements, I'll be giving it to you as soon as possible here, but make sure I want you all to prepare well for mock. Okay, mock is very very important because that is wherein you will understand what are the topics you're supposed to prepare on, where are you lacking, where you need to put extra efforts here, where you're good at. You'll just get the complete clarity over here. Okay, so make sure, try to do this process. Okay, first we'll do first we'll do set, comparable, comparator, and maps. MAP, maps here. So stack I'll do in between. This is just 5 minutes topic. Okay, stack. Okay, that I'll add somewhere in between. Don't worry. Okay, so these are the four major concepts: set, map, comparable, comparator. Okay, so queue and stack I'll add somewhere in between only. Okay, because these are all like 5-10 minutes topic. Okay, so that I'll try to complete it. Okay, so great, guys. Okay, so we shall wind up a session for today and catch up tomorrow. Okay, so thank you all. Take care. Bye bye. Practice well. Okay, so have a nice day.